Hi students. Welcome to Smart Tricks for Study channel. ನಮ್ಮ ಮಾಡೆಲ್ ಪೇಪರ್ ವಿಶ್ಲೇಷಣೆಯ ಅಂತಿಮ ಮತ್ತು ಅತ್ಯಂತ ಪ್ರಮುಖ ಭಾಗಕ್ಕೆ ಸ್ವಾಗತ. ಈಗ ನಾವು ಪರೀಕ್ಷೆಯ ಪಾರ್ಟ್ ಡಿಯಲ್ಲಿ ಬರುವ 5 ಅಂಕದ ಪ್ರಾಬ್ಲಮ್ಸ್ ಬಿಡಿಸೋಣ. ಹೆಚ್ಚಿನ ವಿದ್ಯಾರ್ಥಿಗಳು ಈ ಲೆಕ್ಕಗಳನ್ನು ನೋಡಿ ಭಯಪಡುತ್ತಾರೆ, ಆದರೆ ಈ ವಿಡಿಯೋದಲ್ಲಿ ನಾನು ಈ ಸಮಸ್ಯೆಗಳನ್ನು ಹಂತಹಂತವಾಗಿ ಅತಿ ಸುಲಭವಾಗಿ ಹೇಗೆ ಬಿಡಿಸುವುದು ಮತ್ತು ಪೂರ್ತಿ ಅಂಕ ಪಡೆಯುವುದು ಹೇಗೆ ಎಂದು ಹೇಳಿಕೊಡುತ್ತೇನೆ. ನಮ್ಮ ಈ ಪ್ರಯತ್ನ ನಿಮಗೆ ಇಷ್ಟವಾಗುತ್ತಿದ್ದರೆ ಮತ್ತು ಇಂತಹ ಹೆಚ್ಚಿನ ವಿಡಿಯೋಗಳಿಗಾಗಿ ಈಗಲೇ ನಮ್ಮ ಚಾನೆಲ್ ಅನ್ನು ಸಬ್ಸ್ಕ್ರೈಬ್ ಮಾಡಿ. ನಿಮ್ಮ ಸಪೋರ್ಟ್ ನಮಗೆ ಬಹಳ ಮುಖ್ಯ.
Let's start. Question number 42. A positively charged spherical conductor of radius 0.1 meter produces an electric field of 1.8 into 10 to the power 3 Newton per coulomb at a point P, distance 0.2 meter from its center. Calculate the magnitude of the charge present on the spherical conductor. Also find the magnitude of new charge produced on the same spherical conductor if 5 into 10 to the power 10 extra electrons are removed from it. Answer. Here, given is radius of spherical conductor r is equal to 0.1 meter. Distance of point P from center, small r is equal to 0.2 meter. Electric field at P, E is equal to 1.8 into 10 to the power 3 Newton per coulomb. Permittivity of free space, epsilon naught is equal to 8.85 into 10 to the power minus 12, coulomb square per Newton per square meter. N is equal to 5 into 10 to the power 10, electrons. For a point outside a charged spherical conductor, E is equal to 1 by 4 pi epsilon naught, Q by R square. On equating to Q we get Q is equal to E into 4 pi epsilon naught, R square. Substitute values in above equation. Therefore, Q is equal to 1.8 into 10 to the power 3 into 4 pi into 8.85 into 10 to the power minus 12 into 0.2 square. That is, Q is equal to 1.8 into 10 to the power 3 into 4 pi into 8.85 into 10 to the power minus 12 into 0.04. On simplifying we get Q is equal to 8 into 10 to the power minus 9. Now, for charge added, delta Q is equal to N into E. On substituting values we get delta Q is equal to 5 into 10 to the power 10 into 1.6 into 10 to the power minus 9. We get delta Q is equal to 8 into 10 to the power minus 9, coulomb. Therefore initial charge on the conductor is delta Q is equal to 8 into 10 to the power minus 9, coulomb. Now, for new charge, Q new is equal to Q plus delta Q. That is, Q new is equal to 8 into 10 to the power minus 9 plus 8 into 10 to the power minus 9. Therefore, Q new is equal to 1.6 into 10 to the power minus 8. Therefore, new charge after removing electrons is Q new is equal to 1.6 into 10 to the power minus 8. Next, 43. The terminal potential difference of a cell connected to an external resistance of 4 ohm is 2.4 volt. When the same cell is connected to an external resistance of 9 ohm, the new terminal potential difference becomes 2.7 volt. Find the EMF and internal resistance of the cell. Answer. Given R1 is equal to 4 ohm. V1 is equal to 2.4 volt. R2 is equal to 9 ohm. V2 is equal to 2.7 volt. Using Ohm's law, V is equal to IR. On equating, I1 is equal to V1 by R1. That is, I1 is equal to 2.4 by 4 is equal to 0.6 ampere. And I2 is equal to V2 by R2. That is, I2 is equal to 2.7 by 9 is equal to 0.3 ampere. On using EMF relation, E is equal to V plus IR. Now substitute I1 and I2 in above equation, we get E is equal to 2.4 plus 0.6 R. Mark as equation 1. And E is equal to 2.7 plus 0.3 R. Mark as equation 2. Now, equate 1 and 2, we get 2.4 plus 0.6 R is equal to 2.7 plus 0.3 R. Take R at one side. We get 0.6 R minus 0.3 R is equal to 2.7 minus 2.4. So, 0.3 R is equal to 0.3. Therefore, R is equal to 1 ohm. Now, substitute R is equal to 1, value in 1. Therefore, E is equal to 2.4 plus 0.6 into 1. E is equal to 3 volt. Therefore, EMF of the cell is 3 volt. Internal resistance is 1 ohm. Next, 44. A resistor of 10 ohm and an inductor of self-inductance 0.05 Henry are connected in series to an AC source of 200 V, 50 Hz. Find the impedance of the circuit and current in the circuit. Answer. Given. Resistance R is equal to 10 ohm. Inductance L is equal to 0.05 Henry. Supply voltage, V is equal to 200 volt. Frequency, F is equal to 50 Hz. To find inductive reactance, XL is equal to 2 pi FL. Substitute the values, we get XL is equal to 2 into 3.14 into 50 into 0.05. We get XL is equal to 15.7 ohm. To find impedance of RL circuit, Z is equal to root of R square plus XL square. Therefore, Z is equal to root of 10 square plus 15.7 square. We get Z is equal to root of 100 plus 246.5. That is, Z is equal to root of 346.5. We get Z approximately 18.6 ohm. To find current in the circuit, I is equal to V by Z. Substitute values. That is, I is equal to 200 by 18.6. We get I is equal to 10.75 ampere. Therefore, impedance of the circuit is Z is equal to 18.6 ohm. And current in the circuit, I is equal to 10.75 ampere. Next, 45. Double convex lenses are to be manufactured from a glass of refractive index 1.55 with both faces of the same radius of curvature. Find the radius of curvature required if the focal length is to be 20 cm. Also find the new focal length of the lens if it is immersed in water of refractive index 1.33. Answer. Given. Refractive index of glass. μg is equal to 1.55. Refractive index of water. mu W is equal to 1.33. Focal length in air, f is equal to 20 cm. For double convex lens, R1 is equal to plus R, R2 is equal to minus R. Therefore, lens maker's formula in air: 1 by f is equal to mu g minus 1 into bracket 1 by R1 minus 1 by R2. Substitute R1 and R2 in above equation, we get 1 by f is equal to mu g minus 1 into 2 by R. That is, 1 by 20 is equal to 1.55 minus 1 into 2 by R. Next, 1 by 20 is equal to 0.55 into 2 by R. That is, 1 by 20 is equal to 1.1 by R. On cross multiply, we get R is equal to 20 into 1.1. Therefore, R is equal to 22 cm. Now, using lens maker's formula in medium, 1 by Fw is equal to mu g by mu W minus 1 into bracket 1 by R1 minus 1 by R2. Substitute values in above equation, we get 1 by Fw is equal to 1.55 by 1.33 minus 1 into bracket 2 by 22. Now, 1 by Fw is equal to 1.165 minus 1 into 2 by 22. We get 1 by Fw is equal to 0.165 into 0.091. Therefore, 1 by Fw is equal to 0.015. So, Fw is equal to 1 by 0.015. Finally, we get Fw is equal to 66.7 cm. Therefore, radius of curvature of each surface is 22 cm. Focal length of lens in water is 66.7 cm. This ends Model Question Paper 1 questions with answers. So don't forget to subscribe the channel for more.